Hi, I'm Dr. Hodges, and welcome back to Anther series on Cybersecurity Explained. IPv4 Internet Protocol version 4 and IPv6 Internet Protocol version 6 are two versions of the Internet Protocol used for identifying devices on a network and facilitating communication between them. Let's spend a few minutes discussing the key differences between the two. The address length between the two is significantly different. IPv4 uses a 32-bit address scheme, allowing for about 4.3 billion unique addresses. IPv6 uses a 128-bit address scheme, allowing for approximately 340 undecillion addresses. Address format. IPv4 addresses are expressed in decimal format as 4 octets separated by periods, for example 192.168.1.1. IPv6 addresses are expressed in hexadecimal format as 8 groups of 4 hexadecimal digits separated by colons, as the slide shows in our example. As a side note, leading zeros in each group can be omitted. Address configuration. IPv4 can be configured manually, static, or dynamically through Dynamic Host Configuration Protocol, or DHCP. IPv6 supports automatic address configuration through stateless address auto-configuration, SLAAC, in addition to DHCPv6 for dynamic addressing. Header complexity. IPv4, the header is more complex and includes several fields that can increase processing overhead. IPv6. The header is simplified to reduce processing time and improve routing efficiency, with some fields removed and others made optional. Subnetting. IPv4 uses a subnet mask to define network and host portions, which can lead to complicated configurations. IPv6 uses prefix lengths, e.g. 64, to define networks, making subnetting more straightforward. Security features. IPv4. Security is optional and is often provided by additional protocols such as IPsec. IPv6. IPsec support is built into the protocol, providing a framework for encryption and authentication. Address types. IPv4 supports unicast, multicast, and broadcast addressing. IPv6 supports unicast, multicast, and anycast addressing, but does not have broadcast addressing. Fragmentation. IPv4 routers and hosts can fragment packets. IPv6 only the sending host can fragment packets. Routers do not perform fragmentation. Adoption and usage. IPv4 still widely used but is running out of available addresses, leading to the use of techniques like network address translation, NAT. IPv6 designed to replace IPv4 and address the limitations of address space. Adoption has been increasing, but it is still not universally implemented. IPv4 is still widely used but is running out of available addresses, leading to the use of techniques like network address translation. IPv6 was designed to replace IPv4 and address the limitations of address space. Adoption has been increasing, but it is still not universally implemented. IP version 6 introduces a more efficient addressing scheme, improved security features, and simpler configuration processes, making it well suited for the growing number of devices connected to the Internet. In words, IP version 6 can be expressed as 340 undecillion, 282 decillion, 366 nonillion, 920 trillion, 938 billion, 463 million, 463,374, and that's a lot of addresses, leaving hope that we will never run out. Thanks again for joining us with another series of Cybersecurity Explained.